Welcome back, AP Statistics. This is part 3 of chapter 18, talking about confidence intervals for P, the population proportion. Here is the set of assumptions and conditions we need to check off before we make a confidence interval. Just like pretty much everything else for the rest of the year, there are assumptions and conditions we need to check off on. So, the independence assumption. Data values must be independent of one another, which we can confirm by checking. Now, the conditions are the real important part. The conditions are what allow us to make the assumption, so pay close attention to the conditions. Randomization condition. Data were sampled at random or treatments were assigned at random. And just a heads up for the AP test, they're not going to know what randomization condition means. I mean, they could probably guess. They probably teach from this textbook or those like it. But please use the actual definition of randomization condition to describe why you're allowed to use a confidence interval. So to check off the box, you need to verify that data were sampled at random or treatments were assigned at random, depending on whether you're doing an observational or experimental study. 10% condition. All right, again, they probably know what this means, but please refer to this sentence and use this idea in the context of whatever problem you're doing. The sample consists of less than 10% of the population. Okay, anything past 10%, you cannot assume independence anymore. Now, sample size assumption, all right? The sample size needs to be big enough, which we can check using the success-fail condition, all right? You're familiar with the success-fail condition? Again, they're not going to automatically know what this means, so here is the important part. We need to observe at least 10 successes and 10 fails in our data. We need to observe 10 successes and 10 fails in our data. Now, note, sometimes we need to observe them, and sometimes we need to not observe but expect them. So sometimes this word changes here for the success-fail condition. In this case, for confidence intervals, we need to observe at least 10 successes and 10 fails. All right, so formal definition of a confidence interval for the population proportion. If these conditions are met, the conditions from the prior slide, we can make a confidence interval for P, which is of the form, so centered at P hat plus or minus, so here's our margin of error, Z star, some number of standard errors, times the standard error of P hat, all right? The standard error of the sampling distribution of sample proportions, all right? And the standard error for P hat is square root of P hat Q hat over N, just like the standard deviation, except it's a standard error, so it's an estimate. We use data from our sample because that's the best we got. The greater the value of Z star, the greater the confidence level that our interval contains the true proportion P. That Z star value is the number of standard errors. It is the critical value, we call it. The higher the critical value, the wider we spread our net to catch the true population proportion. Let's do an example. In October of 2015, the Gallup poll, all right, Gallup is pretty much the gold standard for surveys. A Gallup poll asked 1,015 randomly sampled adults the question, generally speaking, do you believe the death penalty is applied fairly or unfairly in this country today? Of these, 53% answered fairly, 41% answered unfairly, and 6% said they didn't know. All right? Question. From this survey, what can we conclude about the opinions of all adults? Okay, now what precisely is this question asking? Specifically, what proportion of adults believe it's applied fairly? All right? Now, we could just say, the 53%, but that is a point estimate. And the thing about a point estimate is it's the best one number guess, but it's almost certainly wrong, and there's no way of knowing how wrong it is. Okay, so we like our interval estimates. We like a confidence interval. But first, we need to check off the conditions. Randomization condition, we see that Gallup drew a random sample of all U.S. adults. We can be confident the respondents are independent, not just because the problem says so, but because Gallup is pretty awesome. 10% condition. The sample is certainly less than 10% of the population. That is certainly true as well. Success-fail condition. Let's look at what we've observed. N times p hat. There's our sample. 53% of that is 538. Last I checked, that is bigger than 10. We also observed, that's why we have p hat here, NQ hat is equal to 1015, that's 47%. 477 is greater than or equal to 10, last I checked. So our sample does appear to be large enough. NP hat and NQ hat are both greater than or equal to 10, so we can use a normal model. So here we go. We have our sample size and our p hat. That means our standard error would be square root p hat q hat over n, which is equal to square root of 53% who said it's applied fairly, 47% who said unfairly or didn't know, divided by 1,015. Again, that 47%, we see 41% said unfairly, 6% said they didn't know. That adds up to 47%, just to be totally clear here. So the standard error is a little above 1.5%, all right? And there you go, there's your standard error. Because the sampling model is normal, for a 95% confidence interval, that is far and away the most common confidence interval that you will run into, and we'll see why that is later on in the year. Much thanks to Sir Ronald Fisher, who we'll learn about a bit later. A 95% confidence interval, the critical value z star equals 1.96. So 1.96 standard errors to the left and right would constitute a margin of error that is 95% certain to catch that true population proportion. Okay, so the margin of error is z star times my number, that's my number of standard errors, times the standard error. So we take our standard error from over here, we multiply by 1.96, and we get a little north of 3%. All right, so that's our margin of error on either side. Okay, so the 95% confidence interval is 53% who said fairly in our sample, so our sample proportion plus or minus our margin of error, And if we were to make that into an interval, which may be a little easier to understand, we would take 53% and subtract 0.031 and get that number, 53% and add 0.031 and get that number. All right, so that is our interval that we are 95% certain would give us the true proportion of people who said it is fairly administered. So we can be 95% certain between 49.9% and 56.1% of all U.S. adults think the death penalty is applied fairly. That is what our confidence interval tells us. That is a practical, bit casual interpretation. Okay? Moving on. Now, you're going to see this slide and you're going to think, Mr. DeClerico, why didn't we do this from the beginning? Well, trust me, you're going to see problems on the AP test that don't give you nice, clean answers. They give you answers that look a bit more like this right here, or look like content on the prior slide with standard error expressed in radical form and all that. They don't give you nice, clean intervals, okay? So sometimes you do need to refer to the format of a confidence interval, z star times the number of standard errors. Maybe the answer is presented like that, so you got to be careful. But if you're just computing a confidence interval, say for a free response problem, it's all on the calculator. We can use a feature called one prop z int, all right? That is a one proportion z interval. That is a confidence interval for the population proportion, all right? So we can do that on a calculator. There are a couple inputs we'll need to keep in mind once we get to the calculator. X is going to be 53% of 1015. Now, what is X? X is the number of successes. 53% of my sample said yes, the death penalty is administered fairly. So the number of successes is 53% of 1015. N is 1015. and sorry, this slide marker is blocking this. The confidence level is 0.95. So let's get over to the calculator. Welcome back to the calculator. We're going to go to Stat. We're going to go over to Tests. And we're going to need to go down a ways till we find one prop z int. We hit Enter. And we have x. X needs to be, it's going to be 53%, so 0.53 times 1015. And if I hit Enter, it'll give me that number there. Now, x needs to be a whole number. All right, so what's going on here? Well, 53%, that's an approximation. And I know that is an approximation because it is impossible for exactly 53% of my 1,015 people to have been surveyed because I get this decimally answer. So how many people actually said yes? Well, we need to round. 538. N is 1,015. Confidence level is 95%. I hit Calculate. And there is my confidence interval, just as we got before, between 49.9 and about 56.1%.